Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder a component in Vero board. Use a soldering iron sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin-coated Vero board for your prototyping. To write the program of firing wheel control, we'll apply a frequency of 50 Hz at RE0. So we'll go to the signal generation, and here we'll select the pulse and we'll place it here in our circuit. We'll connect this frequency generation to the port RE0. Now we'll assign the value to this input. The high pulse voltages are 5 volt. Pulse width is 50% and the frequency is 50 Hz. Here we have simulated the signal of zero crossing input. OK. Now we'll connect the signal of zero crossing at B input of oscilloscope and we'll run the simulation. Here we can check we are getting a frequency of 50 Hz. OK, if we'll change the sweep value, now here we can check the sweep scale is at 2 millisecond and we have 5 boxes on x-axis, that is 1, 2, 3, 4, 5. It means that the total time is 10 millisecond, which is the exit time of the half cycle of a 50 Hz sine wave. Okay, now we'll write our program for firing wheel control. To write the program of firing wheel control, we have to define some more variables. Here we can check we have already discussed that we'll use 2 variables, that is ramp register and FAC register. The ramp register will count during each 10 millisecond and we'll compare the value of ramp with firing wheel control register. So here we'll define 2 variables, that is ramp register and FAC register. And now we'll write the variable assignments. So we'll write unsigned character ramp register equals to 0 and we'll define unsigned character FAC register equals to 0 and we'll also define a flag, that is zero crossing flag. So here we'll write the flag assignments and here we'll write bit zero crossing flag equals to 0. Now we'll use these 2 variables and flag in our interrupt service routine. Now here we'll remove this instruction which is toggling port RE1. Now first we'll compare the value of zero crossing input with zero crossing flag and here we will write if zero crossing input control V equals zero crossing flag control C and control V. If the value of zero crossing input will be equals to zero crossing flag, then our program will come between these 2 braces. And if the status of zero crossing input port will be same as zero crossing flag, then we'll increment the ramp register. So here we'll write ramp register so here we have incremented in ramp register. But if the zero crossing input will not be equals to zero crossing flag, then we'll reset the ramp register. So here we'll write else if zero crossing input is not equals to zero crossing flag, then we'll reset the ramp register and we'll write ramp register equals to 0 and we'll assign the zero crossing input port status to the zero crossing flag. So we'll write ZC FLG equals to ZC input. And now we'll compare the value of fire angle control register with the ramp register. So here we'll write another if condition, and here we'll write if ramp register will be greater than fire angle control register. So we'll copy this assignment from here, Control C, and we'll paste it here, Control V. If ramp register is greater than or equals to fire angle control register, Control C, Control V, then our program will come into this if statement, and here we will write fire angle control output, Control C, Control V equals to 0. Here we can check, we are comparing the ramp register with fire angle control register, and if the value of ramp register will be greater than fire angle control register, we'll set the value of FSE output as low, because the logic of MOC3022 is active low. And here we can check the FSE signal. If the signal will be low, then MOC3022 will be on and the lamp will be on. So here we have assigned the value to FSE out as 0 if the value of ramp register will be greater than or equals to fire angle control register. Now what will happen if the value of ramp register is less than fire angle control register? So here we will write else the value of FSE out signal will be 1. So we'll copy the statement from here, Control C, and we'll paste it here, and we'll change this value, that is 1. In this case the track will be off, and here we can check if the value of fire angle control register will be higher, near to 100, then the fire angle will be near to 180 degree, and if we'll have the low value in FSE register, that is 0, the fire angle will be near to 0 degree. So initially we'll assign a high value to the FSE register, that is 85. So the value of the voltages across the load will be low, because if we trigger the track near to 180 degree, the value of the voltages to the load will be low. So here we'll initialize the FSE register to 85. Now we'll compile the program and we'll observe the result of our program on Proto software. Okay, here we have an error. We cannot initialize the bit value here. So we'll remove this value from here. And we'll initialize the zero crossing flag in main program. Control C. And we'll paste it here. Control V equals to 0. Now we'll compile the program. Okay, there is no error in the program. Now we'll check the program on Proto software. Hex file is already loaded in simulation, so we'll just run the simulation. Okay, here we can see the fire angle is near to 180 degree, and by changing the fire angle control register value, we can change this angle. Let's see. Here if we'll assign the value, that is 50. Now we'll compile the program once again. Now here we can check the firing angle is changed, and now we'll decrease this value further. So if we'll assign the value, that is 5, to FSE register, and here we can check the fire angle is near to 0. Now we'll change this fire angle using switches. For this we'll connect two switches on port RD4 and RD5 of this microcontroller. So we'll go to the components, parts, and we'll select button. Here we have button. We'll also use 4.7 k resistor as pull-up. So we'll write resistor in 0.6 watt category. Here we have a 4.7 k resistor. Okay, now we'll connect the switches with microcontroller. Here we'll place two switches. We'll connect the first switch to port RD4 and the second switch to port RD5. We'll connect both the ends of the switches with ground. And we'll use two 4.7 k pull-up resistors. we'll connect one resistor with port RD4 and the second resistor with port RD5, and we'll connect the second end of the resistors with 5 volt. Now we'll increment and decrement the fire angle control using these two switches. Now here we'll initialize this fire angle control register to 85. In this case, the initial fire angle control will be near to 180 degree. And now we'll call a subroutine to change the value of fire angle control. So here we'll write FAC_R, that is fire angle control routine, and we'll write the fire angle control routine before main program. So here we'll write, and here we will write the fire angle control routine. So we'll write void FAC_R, and we'll write the fire angle control routine between these two braces. So here we'll check the status of the switch, and we'll write if switch increment Control C, and we'll paste it here, Control V equals 0. If switch increment will be pressed, then our program will come into this if statement, and here we will decrement the value of fire angle control register to increase the voltage across the load. So we'll write FAC_REG minus minus. It means that we'll decrease the value of fire angle control by 1. This routine will be executed very fast, so we'll not be able to see the varying voltage across the load. So we'll produce a delay here in decrement of this fire angle control register. And now we'll define two more variables for the delay, and here we will write unsigned integer INC delay equals to 0, and we will write unsigned integer decrement delay equals to 0. Now what will be the value of this delay? Now here we can see we'll change the value of fire angle control register between 5 and 85. The difference is 80. It means that we can control the minimum and maximum voltages across the lamp in 80 steps. And if we would like to change these steps in 10 seconds, so we'll divide the time that is 10 seconds by 80. Now we'll divide the time that is 10 seconds by 80. So each step will require 125 milliseconds. We'll increment these two registers, that is increment delay and decrement delay in interrupt service routine, which is coming at the frequency of 10 kHz. So if we'll multiply this value by 10 kHz, we'll get the value of delay register 10K. It means that we'll move the value that is 1250 to the delay register, and it will give us the time that is 10 seconds from minimum to maximum voltage change. So here we'll check if increment delay is greater than or equals to 1250, then our program will come into this if statement and will decrement the value of fire angle register, and we'll also initialize the increment delay to the 0, and here we will write INC delay equals to 0, and here we will write another condition in our program. If the FAC register is greater than 5, then decrement FAC register. So here we will write if FAC REG is greater than 5, then our program will come into this if statement and it will decrement the value of fire angle control register. So if the increment switch value will be 0 and if the increment delay value will be 1250, then our program will come into this if statement and it will check If the fire angle control register value will be greater than 5, then it will decrement the fire angle control register and it will reset the increment delay register. But if the value of fire angle control register will be equals to 5, then our program will not decrease the fire angle control register any further. Now we'll write the condition for second switch. And here we will write if switch decrement equals 0, then our program will come into this if statement, and here we will check if decrement delay, that is decrement delay, will be greater than or equals to 1250, then our program will come into this if statement, and here we will check if FAC REG is less than 85, then our program will come into this if statement and will increment the value of fire angle control register. So we'll write FAC underscore REG plus plus, and here we'll reinitialize the decrement delay value, that is DEC DLY equals to 0. Now if we'll press the switch, that is switch decrement, then our program will come into this if statement and it will check if the decrement delay register value will be greater than 1250, then our program will come into this if statement and it will check if the fire angle control register value is less than 85, then it will increment in fire angle control register and it will reinitialize the decrement delay value. Now we have completed our routine for fire angle control. Now we'll increment these two registers, that is increment delay and decrement delay, in interrupt service routine. So here we will write INC DLY plus plus. It means that we are incrementing increment delay register in interrupt service routine, and we'll also increment the decrement delay register in interrupt service routine. So we'll write DEC DLY. Now we'll compile the program and we'll observe the result on Proto software. Now we'll run the simulation. Here we can check the fire angle is near to 180 degree. Now I'll press the increment switch. Here we can check the fire angle is changed and the new fire angle is near to 90 degree. If the value of fire angle control signal is low, it means that MOC3022 opto isolator will be on and the trike will be on. Now we change the fire angle further. Here we can check the value of fire angle is near to 0. Now we'll move the fire angle towards 180 degree. Here we can check the value of fire angle is near to 180 degree. Now we have completed our program and we'll download this file into the microcontroller and we'll observe the result on our prototype. We'll go to the file, import hex, and here we have the hex file of the project which we have developed recently. So we'll load this hex file. OK, right. Here we can check the status of port B is high. So first we'll reset all these LEDs connected with port B. So here in the program, first we'll initialize the direction of the port B. So we'll write trace B equals to 0. It means port B is declared as output port. Now we'll initialize the port B value to the 0 and here we will write port B equals to 0, and now we'll compile our program once again. Now if I'll press switch 1, the voltage across this lamp will be increased, and if I'll press switch 2, the voltage across this lamp will be decreased. Now we'll press switch 1. Here we can check the voltage across the lamp is increased. Now if I'll press switch 2, the voltage across this lamp is decreased.